today we're fortunate to have a few minutes with Dr. Alpert Wu, who is the Chief of Pediatric Plastic Surgery, but also the Director of a 3D Printing Laboratory at Brown University. Thanks, Alpert, for agreeing to this interview today.
Oh, of course, it's my pleasure. Thanks for having me.
I've been following your work for several years now, and I have to say, I wish I'm in your shoes, and I wish I could do so much work in 3D printing. You're my idol, in other words. You're a plastic surgeon. Obviously, you just scrubbed out a surgery because I can see
I still have some of the marks on my face.
Yeah, but at the same time, you've done a lot of 3D printing related work, and lately you also have your startup as well. And so we want to basically introduce you to the audience for 3D Heals 2020, because you will be speaking at a craniofacial reconstruction panel, but at the same time, also want to hear more about your startup. But one thing that really impresses me is that you're able to work with the healthcare organization, find resources to achieve the innovations that you have done so far. You want to share some of the early journey, how you got into 3D printing and then finding those early resources and build up upon it?
Absolutely. I think for any of us who have found ourselves in 3D printing, it's kind of a convoluted, non-linear type of journey. I'd say as a plastic surgeon, what I do is I specialize in a field called craniofacial surgery. And basically with craniofacial surgery, I focus on the head and neck region. And so as a plastic surgeon, I do the cleft lip repairs, cleft palate repairs and things like that. Besides that, I also operate on the skull and on the face. And so when you get into a car accident or you get punched accidentally in your face and you break some of the bones, I, as a plastic surgeon, am the person who tries to put everything back together. And so it makes perfect sense that plastic surgeons in particular are the individuals that are most focused on three-dimensional anatomy. And so looking at things from a 2D perspective, say on an X-ray, is not really adequate for us to do what we need to do, because even if we are looking at an X-ray, we need to think from the three-dimensional perspective. I also happened, just as a matter of circumstance, to have gotten my first position at Washington University in St. Louis. And I say that was a fortuitous circumstance because when I got my job, I didn't realize that Jeffrey Marsh was my predecessor before me. And one of Dr. Marsh's great accomplishments during his career was to be one of the two individuals who were credited with developing three-dimensional imaging. So back in the day, back in the late 70s, when we had CT scans that basically cut your face into tiny little slices. But we didn't have a way of actually seeing that as a three-dimensional image. And it's really through the work of Jeffrey Marsh and Michael Veneer, who was a radiologist, where they came up and basically hacked one of the early CT scanners to create three-dimensional imaging. So again, I'm a plastic surgeon interested in three-dimensional structures. I happen to be at a lab that's focused on three-dimensional imaging, so you can kind of connect the dots from there and yada, yada, yada. Next thing I know is I'm sitting with a bioengineer and we decide, it's kind of a cool idea, not only for us to focus on the imaging, but why not be able to print it for ourselves instead of depending on industry where we're paying them thousands of dollars to print those for us. So it happened once again that I'm randomly meet up with a bioengineer. We decide after some positive discussions to put in for a grant. And we were lucky to get an $80,000 grant where we're able to purchase our first 3D printer, kind of a professional grade printer. And from there on, it kind of exploded where now we've got kind of a much higher level printer, but we're able to not just print in a single color, but also multiple colors, and then using that information to three-dimensionally image and then print multiple anatomic structures in multiple colors. and in significantly larger sizes. So we can print out an entire human spine, for instance, when one of the spine surgeons is interested in some of their complex anatomies. So that's kind of my career in a nutshell, at least in 3D printing.
So you mentioned that you wrote a grant. Was this during WashU time, or this is at Brown?
Yes, so it was originally at WashU. Again, it was sometime around 2015 or so where we kind of got this idea. We got the grant around that time. And then we started doing a good degree of 3D printing in 2015, 2016. So it's almost kind of embarrassing talking to people who are experts in 3D printing because I haven't really been doing it for that long. So I've been focused on craniofacial imaging for over a decade, but in terms of actually printing the objects and the designs that we've been looking at, it's actually only been 4 or 5 years.
So the current 3D printing laboratory at Brown, is this based on that particular grant, or you guys got more resources from the university?
Well, so I was on faculty at WashU, and because so much of the work that I did came to fruition there, when Brown University and Rhode Island Hospital had contacted me to see if I'd be interested in potentially taking a position here, I basically told them that it would be imperative for me to have similar resources and access to 3D printers. So as part of my negotiation process, you could say, the printer was purchased for me.
That's awesome. Well, I have so many questions to ask you, because I know that you are not only just working on craniofacial cases, you also have like, specialty, you cover specialties outside of your specialty. You want to share some of the most impressive applications that you have done so far with the lab?
Oh, absolutely. So, my perspective is, and when I came to the university, I told them, look, I'm not here to purchase a 3D printer and hog it for myself. The whole idea is to be an evangelical, so to speak, and evangelize the benefits of 3D printing. And it's actually really kind of interesting that, whereas most of the people in your audience are so used to the concept of 3D printing, those of us in medicine, like we really have no experience with it. And
yeah, I agree.
And one example to that is that, I'm sitting here during the COVID epidemic, and all of a sudden I get a bunch of random emails from people at the top of the hospital administration, and they're asking me if I can print, gowns for people, if I can print soft materials, if I can print masks, and all sorts of things. Some of which are potentially doable, and others that of which are totally impossible. And that really again speaks to the fact that despite having very intelligent kind of national leaders at the head of our hospital administration, they really don't know what 3D printing offers. Everybody kind of thinks it's a magic dust that you can apply. So again, my position here and one of my goals has been to really let other doctors know and use their imagination to kind of expand their horizons. So in answer to your question, what have we done? Like one of the earliest things was when I sat down with the chief of pediatric surgery, and Rhode Island Hospital and Hasbro Children's Hospital in particular has one of the top fetal surgery centers in the country. And so we had a family that was interested in having fetal surgery for their spina bifida. And the surgeons wanted to know what the fetus looked like. And so what we were able to do is get an MRI and then combine that potentially with 3D CT scans to create an image of what that 17-week-old fetus looked like. But besides that, we were also able to get an even better quality image on a fully developed baby, and then use that as a teaching model where we can show not just patients, but also other doctors what the deformity is and give them a much better idea of how to plan their surgeries.
Yeah, I just want to emphasize this is a very complex surgery because a fetus is not born baby, basically. So we're
Yes.
talking about this is a small, small fetus within a woman's womb. So I just wanted to make that clarified to the audience. We're not really in the medical field, how complex and high risk this procedure is.
Yeah. Absolutely. You're absolutely correct in that what I'm talking about is taking a mom who just found out that she has a baby with a spina bifida deformity when she's 20, 25 weeks, and then putting her under anesthesia and then opening up the uterus and making a tiny little hole and then finding the spot on the back where the spinal cord is exposed, and
Yeah.
these kids typically don't walk or have a lot of difficulty with walking and have difficulty with bowel and bladder problems. And so our fetal surgeons basically work through a tiny little hole and then find that spot and then fix it and then basically close up the womb afterwards, and then wait another 20 weeks for the baby to be born. And thankfully that child did extremely well. And was one of our kind of great successes. And besides just fetal surgery, we happen to have one of the top tumor surgeons for spine surgery, and more they're utilizing our 3D technology because when somebody comes over from a different part of the world, from Greece, for instance, and has this inoperable tumor that nobody else can take out, our surgeons really want to know what the complex anatomy is so that they can work around it. And we've been able to provide a lot of those surfaces that have been really kind of game-changing from the perspective of medicine.
Yeah, I mean, creativity takes time. We didn't really switch from hunter and gatherers to cultivating aquacultures overnight. It takes time for people to get used to it. Once they have a tool, and once we have effective communication, like from you, Alpert, and perhaps us, 3D Heals, then more and more people will be introduced to these tools, and we can see these creativities kind of blooming, which is very exciting. Now, speaking of which, you have a new startup.
Yes, absolutely.
Yeah, what is that about? And tell us a little bit about your new startup. What's the name of the startup again?
Yeah, so our startup is called Implant 3D. And the reason I was interested in potentially looking at a startup is because, again, partly through the experience with 3D printing, but also with a lot of my experience with facial fractures, like we talked about before. When you have a break in your cheekbone, for instance, we're putting tiny little metal plates and screws in the face in order to put everything back together. It has never made a lot of sense to me why we have these kind of old style, ancient metallic screws and plates that we're using to kind of screw everything back together. We now have the technology to be able to custom print plates, screws, and even half your skull. If you're missing half your skull, by and large, a customized implant is 3D printed or otherwise manufactured as a custom device. The difficulty from my perspective is that if we go to industry, industry usually takes weeks in order to create those devices for us, and kind of, like anybody who thinks about the future, who watches, any sort of space or futuristic type of TV show, including Lost in Space, you sit there and you think, if I can 3D print, any sort of object, you can 3D print a screw for home or any sort of device. Now you have people working in space where they can 3D print medical devices in space because you can't carry 10,000 pounds of medical and surgical equipment. It makes complete sense to me that we should be able to 3D print our own plates, screws, and customized devices. And technology in the past required that we needed 20,000 pounds of machinery and a 10,000 square foot factory to do that. I think nowadays we have the technology and the ability to be able to do that in a small office space. And so the concept of Implant 3D is that we are basically bringing 3D printing and manufacturing capabilities into the hospital at the end user level, where doctors like myself can actually print it in our own building rather than having to ship it to a different company, waiting weeks for that to be manufactured and then subsequently delivered to us. I think that speeds up the process. It gives the user, like myself, immediate control over the final product, and also allows me to have much more direct input into the manufactured device. So I think that's going to be it's the wave of the future, and I like to think that I'd love to be a part of that. So that's part of the reason for our company.
That sounds really exciting. And one of the biggest topics these days, the last couple of years, is point of care 3D printing.
Yes.
And it is interesting, talking to you. We're both in healthcare space. Like you said, a lot of doctors don't even know what exactly 3D printing cannot do.
Yes.
I mean, very similarly, actually, in the industry, they're trying to figure out how to meet the needs because they're not in a healthcare space. They don't know what we really need and what really works for us. And I think we're trying to create opportunities for conversations to flow both ways. And among those, there are a bunch of other people like engineers and designers and all that, your team, basically.
Yeah, I agree. I think both you and I are kind of a rare breed of individual because it's funny how so much of medicine and engineering and manufacturing all of us are in our tiny little silos. And so I'd say kudos to you and other people. Your organization, 3D Heals, has been such a critical developer of the communication pathways where you can get physicians and people in manufacturing and people in engineering together to kind of solve these problems. So it's very common for me to talk to engineers, and it's very funny how you have these people who have the capability of solving a problem but don't have the problem, and then you have physicians like myself who have a problem but don't have access to engineers who can help solve it for us. So so yes, again, kudos to 3D Heals. It's been really phenomenal.
I am super just honored to be where I am, to be able to have these direct conversations with you and with people who are in the industry who are really passionate about making healthcare better. So I'm very much looking forward to your presentation in June for 3D Heals 2020. And also, you're going to be part of the pitch. So we're going to look forward to hear more about your startup and more exciting conversations ahead. So thank you, Alpert.
Thank you. Appreciate it.